So hello everyone, this is lecture 21 for the mathematical physics, in which we were studying about the matrices, and this is the last lecture for matrix in the mathematical physics. Okay, so in the last lecture we did up to here. Okay, so we did some this rotation and reflection thing. So I hope it is now understood to you that what is reflection and how can you find that it is rotation or reflection. So there is some more complex things, and this is the last thing in the matrix. So I need your full attention. Otherwise it will go over your head. So first let me represent you this D equal to C inverse MC. Hope you remember this relation. We used it in the similarity transformation. Okay, so what is the use of this here? Okay, so first, if there is a frame and it is rotated, means a vector is rotated inside it, then we know how to give the expression for x dash and y dash. Just forget this. We remember these expressions from the previous here when we did this from xy to xy, or from this xy to x dash y dash, then we find these expressions, and these were like this. So this was the matrix. So hope you remember these equations we have found for x dash and y dash. So these are written like this. Now we need to find xy from x dash y dash. So how can we solve these equations? Just multiply with cos theta in this equation, sin theta in this equation, and then minus this equation from this equation. Then you will get the expression for the x. And similarly, if you multiply with cos theta here and sin theta here and just add these two equations, then you will get the expression for the y, and you will get these two expressions. Now we have written xy in terms of x dash and y dash. Now we can write it in the form of matrix. So xy cos theta minus sin theta cos theta x dash y dash. Now this transformation matrix, this one here, it is C, means here we are calling this matrix as C. Now what this matrix is doing, it is transforming r dash to r. So we can write r equal to C r dash. So this is this. So this transformation is in the same plane, means if we have the xy plane and if it is r to r dash, then it can be written from this expression. Okay, and similarly, if there is this two vectors, if it is r, then it will be r dash to r, and if it is r dash, then it will be r dash to r, means capital R. So there are two different vectors, so we can write them like this. Okay, I hope it is clear to you. R equal to C r dash. Now we transform from r dash to r, and here capital R dash to r. So just remember this C. The C represents this matrix, and it represents the transformation in the same plane. Okay, now what is the meaning of C and D here? So I told you what is C. Now what is D? To understand the D, we need to understand some more things. So I told you this, that if there is a deformation in the matrix, so you can see this deformation was in different planes, means r dash was in the x dash y dash plane and r is in the same plane, in the xy plane, and here also r dash in the x dash y dash plane, and capital R is in the xy plane. So this is a transformation in two different planes. Now if we see the transformation in the same plane, means r to r in the xy plane, so it can be represented by m, and this is rotation, just a simple rotation. So as we discussed earlier, so capital R will be mr, means if you operate m on the small r, it will give you capital R in the xy plane. Okay, so let's write from here, substitute the values. R equal to C r dash, we will put here, and small r is C r dash, we will put here. So this equation will become, now multiply with C inverse both sides. So C inverse C r dash, C inverse MC r dash. So this is identity matrix, and from here this is nothing but this D. So now see, we are having this relation in the xy plane, r to r. Now we are having this relation r dash to r dash in the x dash y dash plane. So D present the simple transformation in the this deformed plane, that is x dash y dash. Okay, means r dash to capital R dash in the x dash y dash plane represented by D, as R to R represented by M in the xy plane. Okay, so I hope this is clear to you, what is D and what is M and what is C. Now let's see some definitions. So D gives deformation in the x dash y dash plane, and D is nothing but C inverse MC. Is a matrix which describes in the x dash y dash system the same deformation that M describes in the xy system. So D is the analogy of M in the x dash y dash system. To make D C inverse MC diagonal, the new axis x dash y dash are along the eigenvectors direction of M. If the eigenvectors are perpendicular, then the new axis x dash y dash along the eigenvector directions are set of perpendicular axes rotated from xy system by angle theta. So what was this? Now see, normally what we get when we do this operation, and we put in the place of C, remember x inverse mx from the previous lecture. So in that x, we put the eigenvectors as its column vectors, and then we substitute here values and we get the diagonal matrix. So here this case is always not true, because if you are having some imaginary eigenvalues, then definitely this matrix will not be diagonal. Okay, it will be diagonal only when the eigenvalues of M are all real. Okay, so what is this D matrix? Means if we get this M matrix, and here is C matrix, and this x dash y dash planes are nothing but the eigenvectors of M, and they are perpendicular to each other, then C represents the rotational matrix, and the rotation will be of angle theta. So I hope this is clear to you. If it is not, then you will see the examples and it will be more clear to you. So if we find the eigenvectors and these eigenvectors are perpendicular to each other, then in that that eigenvectors represent actually the axis of the new plane, okay, after rotation of angle theta. So if there is this r1 vector and there is this r2 vector, so we can find the components, means we can find this C matrix. How we can find this? R1 represent the first eigenvector, which is, and R2 represent the second eigenvector of that matrix, and they are perpendicular to each other. So let's see the components of these eigenvectors. For this, if the rotation angle is theta, then for R1 if magnitude is 1, then x component will be cos theta and y component will be sin theta. So x1 y1 are cos theta sin theta. And for the second eigenvector, if we see, then this is 90 plus theta. So cos 90 plus theta will give you minus sin theta. So this is x2 will be minus sin theta. And then sin 90 plus theta will give you cos theta. So this will be the rotational matrix, and this represents the rotation. Okay. Now, thus matrix C, which diagonalizes M, is the rotation matrix when the x dash y dash are along the direction of eigenvectors. Just remember this, that x dash y dash are along the eigenvectors, okay, of that matrix. Only then this all formulas will be valid. Now what we discussed here, that the transformation from small r to capital R represented by M in the xy plane. Now, and then transformation from r dash to capital R dash represented by D in the x dash y dash plane. And D is nothing but C inverse MC, where C is nothing but the eigenvectors of M, which are perpendicular to each other, and then they represent the rotation. This C matrix represents the rotation matrix, and theta angle inside this matrix represent the angle of rotation. Okay, and D is not need to be always diagonal, because it depends on the eigenvalues. If all the eigenvalues are real, then we will get the diagonal matrix. If not, then we won't get the diagonal matrix. So in 3D, we are seeing that we are rotating along the xy plane. So let's say this z axis as the rotation axis. Then we represent this matrix here, cos theta minus sin theta cos theta, and this third axis represent the rotational axis. Okay, so that's how we can write it in the 3D if we are rotating along the z axis. So this plane is defined. This z axis along the rotation along the z axis and xy rotation is this system is defined. Now we will given the system will be given to us, can be in any rotation axis. We need to transform that system into this system. this is the actual thing we will do. Means we will transform any system to this system and we will find the angle theta. So that will be do, and this type of question will be asked in the paper. Okay, so determinant of this is 1, so only rotation is involved with angle theta. But if determinant is -1, so reflection is also involved, that's why we are getting this -1 here. Means z-axis is also reflected. If you operate 0 0 1 here, you will get 0 0 -1. So it represents that rotation is reflection is also involved when determinant of the matrix is -1. And trace of this matrix will be 2 cos theta -1, and trace of this matrix will be 2 cos theta +1. Okay, and as you know, this is just a similar to the original matrix in the different, is just in the different planes. So trace will be equal to original matrix also. Means trace of this matrix you will get will be equal to trace of that matrix M. So we'll use these properties. Let's see one example. This question is given 1 by 2 root 2 by 2 1 upon 2 minus root 2 by 2 0 pi by 2. This is not pi by 2 actually, this is root 2 upon 2 root 2 upon 2 1 upon 2 minus root 2 upon 2 1 upon 2. When you solve this, you will get the determinant as 1. So we will say that rotation is involved because we are getting determinant equal to 1. So as we did earlier, to find the rotation axis, we will put AR equal to R because rotation axis will remain same, it will not transform. So after solving this equation from here, you will get rotation axis as this 1 upon root 2 I cap plus k cap. This is rotation axis. Now see what we will do. This is rotation axis in this plane, whatever which this plane is. Now we will transform this plane into this plane. So we will consider rotation axis as z axis. Okay, so just write it at the position of here. We write it here 1 upon root 2 0 1 upon root 2 in the place of z axis. Now this new system should be perpendicular to each other. So here we need to just do this by ourselves, that product of these two vectors should be 0 because they should be perpendicular. So we write it here 1 by root 2 and minus 1 by root 2 so that the product of these two becomes 0. Okay, then to write this third vector, we will take the cross product of this and this vector to get this vector so that all three are perpendicular to each other. So this is our new system C. Now we will diagonalize using this because now we can see that this will be the eigenvectors. This will be the eigenvectors for this matrix. Okay, now how can we diagonalize this? C inverse MC. So use this matrix C inverse A C. So we have C here, so C inverse will be like this. C inverse AC, you will get this matrix then. So now it is transformed to in our plane which we were talking about, means this plane where z axis was the rotation axis and it is rotating across the xy plane along theta with angle theta. So after this we will get this type of matrix. Now here rotation is along the z axis, and now we can compare the values here, means from here cos theta and sin theta. So you will see cos theta is 0 and sin theta equal to -1. So after comparing, you will get theta should be 90 minus 90 actually, so that both can be satisfied. So the rotation will be clockwise direction with 90 degree. Okay, so that's how you can find the angle of rotation. So okay, so hope this is clear to you. Let's take one more example. Now there is this matrix, determinant is -1, so reflection is also involved. So we'll take this condition BR equal to -R. Because the reflection is involved, that's why the axis will be reflected only and rotation axis will remain same, just reflected. So R will came out to be this, and this is also a rotational axis. Now to find the plane of reflection, what you will do, just take a R vector in the plane xi cap plus yj cap plus zk cap, and dot product with this will give you 0 because this is perpendicular to plane of reflection. So you will get this equation x minus y plus z equal to 0. So this is the plane of reflection, and you have the rotation axis. Now as we did in the earlier question, just write it as on the z axis 1 by root 3 minus 1 by root 3 and 1 by root 3, and take the perpendicular vector to this, which will be this. We just assume these values so that product of these two values can be 0. You can take any values here, answer will remain same. So it is 1 by root 18 minus plus 1 by root 18, so 2 upon root 18, and it is minus 2 upon root 18, so it will give you 0. This a dot b or v dot here will give you 0. Now to find the perpendicular to both of these, we will cross product these two vectors and we'll get this. Now just find out the inverse and do this calculation, C inverse BC. You will get this form which we already discussed here. You will always get this type of forms after doing the operation. Now here reflection was involved, so we will get this kind of matrix where z axis is rotation axis. Now comparing these values, cos theta minus sin theta. Here cos theta should be minus 1 by 2, sin theta should be root 3 by 2. So we'll get theta is, it is cos theta and minus sin, yes. So theta should be 120 degree, so because it is pi minus 60 and it will give you cos minus 60, so minus cos 60 and it will be minus 1 by 2. Here also if theta is 120 degree, you will get sin theta as root 3 upon 2. So theta will be 120 degree in anti-clockwise direction. Because theta is positive, then it will be anti-clockwise direction. So rotation will be 120 degree along the anti-clockwise direction. Now there is one more example. Let's see. F is given this and determinant of f is 1. So rotation will be involved. If we find the eigenvalues, then they all are real. Now if we diagonalize this matrix, so we will get the diagonalized matrix actually after applying the operation. First fr equal to r, find the rotation axis, then do the same operation. Well, we don't need to do the operation here because we know all the eigenvalues are real. So just write it as minus 1, 1 and 1. Here we need to find that z axis as a rotation, that's why we written 1 here and minus 1 here. So if all the values are real, then just write the eigenvalues under this. You don't need to do all these operations, this inverse and all. If you try to find eigenvalues here, then you will find these imaginary values. That's why we are not applying this condition in that question. So here you can write them. This question is actually asked in the JEST exam, so you can write directly minus 1, 1, 1. Now you can compare this with this. So cos theta, sin theta should be cos theta should be minus 1 and sin theta should be 0. So you will get theta equal to 180 degree from here. So it will be 180 degree rotation, anti-clockwise direction. And also you can find theta by this as trace of this matrix, means trace of this matrix or this matrix will be equal. So you can write them. So what will the trace of this matrix? It will be minus 1, and trace of this matrix will be minus 9. It will be minus 7 divided by 7, it will be minus 1. So all trace will remain same, and this matrix is similar to this matrix, this one. So 2 cos theta plus 1 will be equal to trace minus 1. From there you can find it will be minus on this side, so it will be minus 2 cos theta equal to minus 1 at theta equal to 180 degree. So that's how you can solve it directly. So if you are still having any doubt, then put it in the comment section. Now matrix is complete for us. From the next lecture we will start the ordinary differential equation, all about the differential equations we will complete it. Okay, so that's it. Thank you.